In this video, we're confronted with a problem which involves a mystery hydrocarbon that was burned in excess oxygen, and effectively what is produced is 404.976 grams of carbon dioxide and 165.672 grams of water. Now, using this information, we've been asked effectively to determine the empirical formula of the hydrocarbon. One of the first steps which I would take to approach this particular problem would be effectively these values. We need to convert them back into moles effectively, or we need to convert them into moles, and this is to enable us to compare the molar quantities in these formulas. Now, in this particular case, we've got 404. Okay, let's just 404.976 grams of carbon dioxide, and we've got 165.672 grams of H₂O, right? Now, we need to get the molar masses of these two of CO2, the molar mass of CO2, and we need to get the molar mass of H₂O to be able to progress in this question. And so I would invite you to refer to the periodic table to try and work this out, right? And if you do that, for carbon dioxide, we would get a molar mass of 44, right? 44. And for H₂O, effectively, we would get a molar mass of 18. So MR of H₂O is equal to 18, right? And at this stage, we refer then to the equation which relates molar mass, and moles, right? So we know that the mass, or should we say the moles, since we're working to get to the moles. The moles is equal to the mass in grams divided by the molar mass in grams per mole. So effectively, for both of this side and this side, we're going to need to do 404.976 divided by 44. Here we're going to need to do 165.672 divided by 18, right? So if you do that, and on this side you need to do 165.672 divided by 18. So at this stage, I would invite you to have a go on your calculator to work out what these values come to. Now, if you had a go at working out on your calculator what that is, what you should have found is that both of these values, when you divide them by the respective numbers, here you get 9.204, right? And here you also get 9.204, right? Now, this, to be clear, is a ratio between CO2 and H₂O, right? So I'm going to just make that clear. So CO2, so this is moles, right? So I'll just put N for moles. So the moles of CO2 compared to the moles of H₂O, the ratio at the moment is 9.204 to 9.204. At the moment, what we have are not whole number ratios. Okay, so as you can see, we've got some decimals there. What we're going to do, because what we're aiming for is to get to as close as we possibly can to whole number ratios, we're going to divide both sides of this ratio by 9.204. Okay, so if we divide that by 9.204 and we divide this side also by 9.204, based on visual inspection, you can, it's quite straightforwardly figure out what that would come to, but you can, if you need to, you can have a go on your calculator. But what you should get from that is that that forms a 1-to-1 ratio, right? Now, in this particular case, we know that these products came from the combustion of the hydrocarbon, right? And we know that if H₂O is formed, and we know if CO₂ is formed, given the only external product was oxygen, or should I say the only external input, not product, but the only external input was oxygen, we know that the whatever moles of hydrogen was produced and the moles of carbon that were produced came from the hydrocarbon itself, right? So we can and we know that because also it was burned in excess oxygen, right? Okay, now because of this, we can actually, okay, we've got a whole number ratio achieved. Okay, we can now look at the carbon and the H₂O and say, okay, well, if we have 1 mole of CO₂, how many moles of carbon do we have, right? And now we're going to form a new ratio, right? So this is going to be the moles of carbon compared to the moles of hydrogen. And I'm just representing this literally as a H. Now here we can see that in CO₂, we've got 1 mole of carbon for every mole of CO₂, right? So this is going to be a 1 here. Here on the other side, with regards to H₂O, we can see that for every mole of H₂O, we've got 2 moles of hydrogen. So here, because we've got 1 mole of H₂O, we can figure out from that okay, we've actually got 2 moles of hydrogen, right? Now this is and we can confidently assert that this is the smallest whole number ratio that we can reasonably get, given the numbers we've got here, right? And therefore we can say that the empirical formula would be carbon with a 1 associated and hydrogen with a 2 associated, right? And of course, when we're writing chemical formulas, we don't literally write the 1, right? I'm just writing that for the purpose of seeing the comparison of the ratio. Therefore, we know that the empirical formula in this particular case would be CH2. Okay,